So today we're going to be working on 4.9 in your algebra book. We're going to be looking at absolute value in equations and also inequalities. So we've worked with absolute value a little bit. That's the distance a number is from 0. So how far is 4 from 0? 4. How far is negative 4 from 0? Also 4. So anytime we take an absolute value, just remember that the answer is going to be positive because we're measuring a distance. There's no such thing as the absolute value of a number being negative. Okay, absolute value is the two bars that we see on the outside. You can see these examples, absolute value. It basically makes whatever's on the inside positive, okay, because it's asking you for a distance away from 0, or in these situations, a distance away from a certain number. It could be to the left, to the right on a number line. It could be less, it could be more. It could be, as we've talked about in the last section, a plus or a minus. So we're going to represent these with absolute value. And the big idea is inequalities with the absolute value in this standard form that we're used to, ax plus b, on one side, and a positive number c on the other, because it must be positive. It's the absolute value of something, it's got to be positive. They can be solved by using the fact that this must equal either c, so the positive, or it could have equaled the negative version. So if we have some expression inside the absolute value, and it equals, let's just say 2, we know that the inside of the absolute value either produced 2 on its own, or it produced negative 2, and the absolute value then made it positive 2. So a lot of times in these, there's going to be two possible answers, and they're going to be opposites, the positive and the negative version. But it's not always going to be 2, and we'll talk about that right here. There's 3 different situations when solving these equations that have absolute values. So the most common is when there's 2 solutions. So this occurs when the absolute value is set equal to a positive number like 3. So the inside could have produced the number 3, or it also could have produced the number negative 3, and they still would give the absolute value being 3. Okay, so there's 2 possible answers there. Situation 2 now, we only have one possible answer, and that's when it's set to 0. So if this is producing 0, that means that whatever's in there is just creating a 0. There's no negative 0. So the absolute value didn't change a negative 0 to a positive 0 because that just doesn't exist. So there's only one solution if it's set equal to 0. And then there's no solution if it's set equal to a negative number, because it's impossible. You can't take the absolute value of a number and get a negative. It's always positive. So in that case, it's no solution. All right, so let's go down and actually solve some of these, see what we get. So in this case, since this is equal to a positive number, there's 2 possible answers. So we're going to actually do 2 separate equations. So inside of here, if we got the answer 3, one of the possible ways we could have got that is if this expression actually produced a positive 3. So we want to solve and say, what does x have to be if it's producing positive 3? But it also could have produced a negative 3, because if we plugged something in for x and got negative 3, the absolute value would then make it 3. So we also need to know, what could we plug in for x that would produce a negative 3? So we need to know both of those possible answers. So real quick, running it over here, we all know how to solve these. So we're going to eliminate the 5. And then divide by 2. So x equals 4. Over here, we're going to add 5. Now we're going to get 2, divide, and x equals 1. So these are our 2 possible solutions. Okay, so there's always going to be 2 when this is a positive number. 2 answers. I can plug in 4 and get the answer of 3, or I could plug in 1 and also get the answer of 3. And just take a look. If you plugged in 4, 2 times 4 is 8, 8 minus 5 is 3, and the absolute value of 3 is 3. If I plugged in 1, 2 times 1 is 2, minus 5 is negative 3, and the absolute value of negative 3 is 3. So 2 possible answers. Now, if it's equal to 0, there's only one possible answer. This has to produce 0. So we just want to know, when does 3 minus 4x equal 0. All right, so eliminate the 3. And we get negative 4x equals negative 3. Divide by negative 4. These cancel. Two negatives make a positive, and we're just going to leave this as 3/4. So if you took 4 times 3/4, you'd get 3. 3 minus 3 is 0. Absolute value of 0 is just 0. That's the only answer, though. There's not 2, there's just 1. And right over here, if we look at this, what can we plug in for x that when we multiply by 9 and add 2 and then take the absolute value, get negative 10? Well, right off the bat, I know there is no solution. Okay, it is impossible to produce a negative with an absolute value. So let's write that down. Absolute value cannot equal a negative. All right, so those are your 3 different situations. Positive number, 2 answers. 0, 1 answer. Negative number, no solution. Now, when we put these on the graph, they're not going to be straight lines. They're going to be 2 straight lines that intersect and then kind of go somewhat in opposite directions. And they're going to make these V's. And so we're going to see a point where it was 0, and that's our 1 answer. And then as we look at these y equals different numbers, there's going to be 2 possible answers at each point. So this is a good representation of this. So when it's 0, there's 1 answer right here at the intersection. There is no negatives down here. The lines always stay in the positive. There's no answers that are negative. And as we look at these answers, 2 and 4 and 6 and 8, there are 2 possible answers for each one. All right, so we're going to use the graph of y equals absolute value 7 minus 2x at the right to answer each of the following. So when does this equal 8? Okay, now we're just going to use the graph. We're not going to go ahead and solve it like we did up here. Using the graph, go to y equals 8, okay, because it's y equals, so 8 is in the y spot. And so when y is 8, these lines here represent the expression absolute value 7 minus 2x. So there's 2 possible answers. And of course, that makes sense with what we did up here. A positive number has 2 answers. So where do we find them on the graph? So you want to think about your line, y equals 8. It's that horizontal line that hits the y-axis, and you go left to right. The x value changes, but it never goes up and down. It's always y equals 8. So what are the 2 values that it hits at? It hits at x equals exactly negative 1/2, or negative 0.5, however you like to write that one. But then it also has another answer right here, and that would be x equals 7.5. So those are the 2 possible answers. Now if you go to y equals 0, so when does y equal 0? It's only going to happen in this one spot, 1 answer, 1 solution. And that's when x equals 3.5. And then when does this expression, the absolute value of 7 minus 2x, equal negative 2? Well, if you look down here at negative 2, or any negative number, these lines will never go down there. No solution at all for any negative number. All right, so that's when we have these equals. So we've studied equations, we've also studied inequalities. So now let's apply the absolute value to our inequalities. If you flip it over, there's 2 different situations when we're solving inequalities. Situation 1 is when they are less than or equal to. So this number has to produce something that is less than 8. So it could produce a positive number less than 8, or it could produce a negative number that becomes positive because of the absolute value. And think about what those numbers would have to look like. Okay, they actually have to be greater than negative 8, as in negative 7, negative 6, because when you make those numbers positive, now they're less than positive 8. So we can't have numbers being produced in here that are actually less than negative 8, because if we did that, like say negative 10, well, the absolute value is going to make it positive 10. And positive 10 is not less than 8. So these numbers in here, and we're going to talk about it specifically in the next example, but they're going to have to go inside the interval of -8 to +8. They're going to have to be less than +8 and more than -8. So situation 2 now is when we need a greater than. So the absolute value has to be greater than 6. And so when you think about that, this could produce a positive number bigger than 6. That's the obvious. It's the negatives that get tricky. So if it's going to produce a positive number greater than 6, but it's going to be a negative answer in here, that number actually has to be less than -6, like -7, because then it becomes +7 with the absolute value, which is greater than 6. So it's the negatives where this gets confusing. Sometimes a graph can make this a little more clear as well. So we're going to look at the graph. We're actually going to play around with the graphing calculators with this as well. So as we slide down here, we're going to solve each of the following for x. So first of all, this 2x plus 6, if it's going to be less than 8, and we're just thinking positives, 2x plus 6, when is it less than 8? But we also want to know, when does this produce a negative number that when you make it positive is less than 8? So those numbers would be like -5. Make it positive with the absolute value, and 5 is less than 8. Okay, not -10, because -10 would become +10.